Today we're going to do an example of writing an equation in standard form if we're given the vertex and a point on that parabola. So in my example here it says write in standard form if the parabola passes through the vertex 1, -7 and the point -2, 29. Okay, so let's recall standard form. So y equals ax squared plus bx plus c. Okay, so if we're just given the vertex and a point, we really don't have enough information to just write this information into a standard form equation. So we're going to need to first work with an equation that we're more familiar with using the vertex. So the thing that comes to mind would be, or should be, vertex form, which is y equals a x minus h squared plus k, where the vertex is the point hk. Okay, so because we know the vertex from the question, we can easily substitute that point into the vertex form equation. So we're going to have y equals a x minus 1 squared minus 7. So that's just me subbing in the vertex into vertex form. And now we're going to need to find our a value. But in order to do that, we need to have an x and y. Well, the x and y come from the point here, -2, 29, where -2 is our x value and 29 is our y value. So we can take that point and sub it in for x and y. And we're doing this because we want to find our a value, because a also exists here in the standard form equation. So let's do that. So we're going to have 29 equals a x, which is -2, minus 1 squared minus 7. Okay, and now we can just use BEDMAS to find, to clean up this equation, I should say. So we have 29 equals a, well, -2 minus 1 is just -3 squared minus 7. And I have 29 equals a, well, -3 squared, well, any number squared is going to be positive, so 3 squared is 9, minus 7. So now I just have a linear system of equation here. To solve for a, I need to bring 7, or this minus 7, over to this side over here. So I need to add 7 to both sides. So 29 plus 7 equals, and I'll just write this as 9a minus 7 plus 7. The reason why I needed to add 7 on both sides is because now I have a minus 7 plus 7, which is just 0. So these will actually just kind of cancel out there. So I'm left with 29 plus 7, which is 36, equals 9a. Divide both sides by 9 to get rid of the 9 in front of the a. So 36 divided by 9 gives me 4. So a equals 4. Perfect. So now that I know this, I can substitute a back into my equation here. I'll square that. Okay. So I'll work on this side over here. So now I have y equals 4 x minus 1 squared minus 7. So now I have a completed vertex form equation. Well, to get to vertex form to standard form, what I need to do is I need to expand this bracket and then FOIL it and then distribute the 4 throughout the bracket to collect all the terms in the bracket. But let me show you this firsthand here. So y equals 4, and now this x minus 1 squared, what that means is literally x minus 1 times x minus 1. So I have 2 sets of that, minus 7. Okay, so now I need to FOIL my 2 brackets here. So that'll give me x squared minus x plus 1 minus 7. And I'll just collect my like terms inside the bracket there. X squared minus 2x plus 1 minus 7. And now I need to take this 4 in front and distribute it through the bracket. So I need to multiply each term in that bracket by 4. So I'm left with 4x squared minus 8x plus 4 minus 7. And then I have y equals, collecting my two like terms at the end here, 4x squared minus 8x. 4 minus 7 is just negative 3. So what I've done by foiling those two brackets there is I've now created an equation in standard form, right? It follows ax squared plus bx plus c. So this is my equation here in standard form. So I hope this helps. Make sure to like, comment, and subscribe if this helped you guys out. I'll be posting more videos throughout the week. Thanks for watching.